Yeah. Yeah. Is that a big deal? Okay. Okay.
Are you gonna put your back on the tomorrow? Yeah, if that were to happen, would it get pushed back?
It would. Do you really think that there's a chance? Okay.
It's just like
So maybe. You know, if the wind chill pushes that -30, like that's what we need, is that negative
30.
I don't know, but -20 is not going to do it. Mm-mm. It's not going to happen. Okay, so now we're going to rotate about vertical axes today. Okay, so we'll start by rotating about the y-axis. And when we do that, we are going to have to integrate with respect to y. And our outer radius is going to be an equation in terms of y minus our inner radius, an equation in terms of y. So what I want you to notice is that these rectangles are perpendicular to the axis that we're rotating it about. Okay, now that's all we know, but on Monday, I'm going to teach you the shell method, and we'll talk about the difference between the disc washer and the shell method. You call it what you want.
What I was thinking, that makes some sense.
Have you ever looked on the inside of your dishwasher? There is a probably a good thing. Your dishes could break. Write down this example before I completely lose you to dishwashers.
Oh wait, dishwasher. No, you wait. I know someone else who has a window on the dishwasher. I was thinking about champagne time.
So we have y equals 0, x equals 2, and y equals 2x squared. Right now, the forecast is for -20 wind chill in the morning. So it's gonna need to change. Oh, really? Okay, so we're gonna rotate across the y-axis. Now, I'm gonna blow your mind a little bit here. We need our rectangles to be perpendicular to our axis of rotation if we want to create discs or washers. So I like to call this the perpendicular rectangle. I know, right? Perpendicular. Perpendicular, and we're doing the disc washer method. So it's a perpendicular rectangle. All right. Okay, now I do have a problem though, because we're gonna have to be in terms of y. Is this equation in terms of y? No. If we solved it for y, it would become, or if we solved it for x. So technically it'd be plus or minus, but since we're only working with this half, which half are we working with? The positive, okay? If we had both sides of the parabola, one would be the positive, one would be the negative, okay? All right, so here we go. We have pi integral of r squared minus r squared h. Well, now our h is dy. Fine. Okay. Let's talk about our limits of integration. Well, it looks like we begin at 0. What is the y coordinate of that intersection point right there? 8. Where does x equals 2 intersect with y equals 2x squared? What?
Yeah, so 2 equals, wait a minute.
So, well, I just plugged it in right here. Yeah. Okay. All right. Which part of our rectangle is furthest from the y-axis? Okay. So our outer radius is 2. I'm not going to write -0. Okay. And then our inner radius, our piece of a parabola is the closest. So that's our inner radius. Okay, help me out. That's 9. Don't worry about the pi until after your math 9. Well, I used to go to math survey, but now we're. Wow. So he's saying negative. You get something? 16 pi? Really? Seems like a nice number. Oh, you know, if I was really thinking ahead, I could have made all of our answers like 2 pi, 2 pi. I didn't think far enough ahead. That's okay. That would've been 11.
That is technically 2 squared squared. It's true. Well, it's 3 2's in there. That's it, right? 2 squared squared. There's already 4.
Yeah.
But that's, 4 2 squared squared is 3.
Okay. So you're right. I did plan this. Yes. Yes.
Our challenge is to make every single one.
Okay. All right. Let's go ahead and do this one. Oh my goodness. I think it's time for a parent-teacher conference. Yep, Geo 1. He does. It looks like a football, squish football. Like a corn cob. And I'm hungry. I'm always hungry. I got to go to the Olive Garden soft opening this weekend. Uh-huh. It was pretty good.
It's cold as we sit in my car. It's fine.
Okay, so we're gonna rotate around the y-axis, which means we need a perpendicular rectangle, which has thickness dy. Okay, so when we set up our integral, we're gonna have pi integral of r squared minus r squared h, but this time our h is our dy. Now, before we start plugging everything in, do we have equations that are solved for x? No. So y equals square root of x, we are going to write as what instead? X equals y squared. Okay. How about y equals x squared? Since we're on the positive side, we only need to worry about x equals square root of y. Okay. Isaac, what are our limits of integration? 0 to 1. Excellent. Okay. Our outer radius. Nathan, what is it? Aaron. Okay. X equal what? Radical y? Okay. And then our, do you like stand up? Okay. What? What's our inner radius? Okay, find that for me. You're like, that's trans. Hey, look. Focus on it. Focus on it. Focus on it.
That's not comfortable.
Okay. You don't think you can stand up?
I probably could, but
Okay. What's gonna help?
I had no idea.
Okay. Do you like water? Can you take a drink of water? You don't have water? Okay. Can you like grab your phone? Like give it to Kylie? Like reach it out to Kylie?
Yeah.
Look at that. Okay. What about your other hand?
Yeah.
What helps it?
Normally I just it stops.
Okay. Okay. Is it 2 pi? No. What is it?
3 pi over 10.
Well.
So you can change the bottom to 2 plus 2 plus 2 plus 2 plus 2. And then you can change the top to, in parentheses, 2 + 2 + 2 divided by 2.
Thank you.
Squared minus
2 over 2.
squared divided by 2 divided by 2. 2 squared. Plus 2.
Hold on. 2, so this is 4, and then times, okay,
Put 2 in the front.
8 plus 2. Hi.
Just do 2 + 2 + 2.
That's actually.
Yeah, you just made 18. You need to do
Big minus
2 and then quantity of 2 squared.
2 out front for the 2 squared.
Okay, 2 times 2 squared.
Yeah.
Plus 2, now we're good? Okay. We don't actually have to write this answer, people. The 3/10 pi is what I need. It is happy Tuesday. Okay. All right. Now what happens if we rotate around a line that isn't the y-axis?
Yeah.
You just said that 3 seconds.
If I was on my.
You said that 3 seconds.
No proof.
But I didn't know.
So it's the same region. We're just going around x = 10. My drawing is probably not drawn to scale, but I would like to leave some room. Okay. Okay. Our limits of integration are still 0 to 1. We have our pi. Here's our r squared minus r squared. H is our dy. Hey, guess what? If you leave off the dy or the dx, it's not set up properly. I will dock you points. Okay, we understand? Okay. Our outer radius. Which piece of the rectangle is furthest away? The blue one, the y squared. Okay, this is our outer radius. Now, when we take right minus left to get this length, we have 10 minus y squared. Okay. The inner radius take right minus left, we would have 10 minus square root of y. Now, I'm a little nervous. It might not be rational because of that square root of y.
So.
This one.
Two.
What did you get? 20.001. Notice how we got an irrational number. So I just multiplied the irrational number by pi, and then our final answer is a decimal with pi already in there. Don't put 6.366 pi.
I even wrote two plus two. Then as an improper, not improper, as a mixed number, we can have the fraction 2 squared over 2 times 2 times 2 plus 2 divided by 2.
Alternatively.
Are you trying to do that?
Yeah. No, I'm trying to do 6.366 because
You have
6.366
to use
is just
that.
6 and 9. So,
So you're saying that it could be a fraction?
well, it shouldn't be, except
It's an irrational number.
it's an irrational
But
number.
if you
it's really
round for
close
3
to the
decimals.
Oh, no. You can't take an irrational number and make it a fraction.
Oh, but I really want
Well, that's not how that works.
I don't.
Fuck it.
Okay, somebody that's trying to do the notation. So it's all over.
Okay. How about this? Nathan,
Is that allowed?
no, it's not, but
Why don't you just like,
That's not how numbers work.
no, it's not.
wait.
Can it be?
No, no.